Right, welcome to our second objective, which is differentiate between geographic and projected coordinate systems. Now, we're not going to go into some crazy detail and all the math and everything that is associated with with all these coordinate systems, but we're going to definitely give an overview of what to expect. So the two objectives that we're going to cover is define coordinate systems and compare and contrast geographic and projected coordinate systems. So let's start off with coordinate systems. So in our first lecture, we introduced this concept of like the X and Y and possibly Z. And so with this, what we're going to say, what's defined is this graphical display of position. So you can think about it in terms of like Cartesian coordinate systems, for example. We have a x-axis and a y-axis, and that gives us this graphic that we can see and we can place data. So when with that x and y coordinate system of the, or not coordinate system, of this graphical display, some of that is very relative. So that's what this is trying to say. So when you look at one particular graphical display, you may not understand where the data is actually from. So where does the actual zero stand? Where is it actually located? And then what procedures were followed to make sure that this is actually where it is? Because anybody can come up with an X and Y coordinate system. In fact, we do it in land surveying a lot of the times when we're working in a very local area. We'll just say, well, I'm going to set 0 here, and I'm going to put 0 there, and I'm going to draw a line, or like a 0 and 1 here, and I'm going to draw a line between them. So, but how do I actually position that based on the Earth's surface? We need to have a definition of like what are the limitations, because sometimes there's a limitation. So that we have to remember that with walking into coordinate systems, those are very important concepts. So the limitations especially need to be understood, because there are going to be errors, there are going to be that are always built in, it's inherent in anything that you have that's data. So we have to understand that, and we have to know what those are, so that if we give something to our client, we can actually tell them what the limitations of that data is. So one of the basic things that we need to remember is how can we reference our data on the ground. So the coordinate system is a system for referencing ground positions, and specifically on the Earth's surface. Unless you're mining, then you might be subsurface. And these systems have to have a starting point, which is also known as an origin. So that reference point or starting point is the origin of the coordinate system. Then everything else can be determined by a distance and direction. Now, if we use that, and for those of you who have any math background, or those of you who have any background in location and spatial information, whether that be drafting or geomatics or what, a distance and direction is considered polar coordinates. So it is a type of coordinate system as well. So, but we can say we have an origin, and then we can go from the origin to the point. We have a distance, and then we also know the direction based on the axes of the coordinate system itself. And so every coordinate system has a different way to define that position, whether it be on curves, whether it be straight lines, and where that X and Y direction is actually pointing. So when we say georeferenced data, going back to the previous lecture, geo is Earth, referenced means based on something. So it is data that is based on the Earth. And so what does that mean in terms of coordinate systems? Well, it means that we need to know where something is located on the Earth's surface so that we can actually position it accurately every single time. So the first type of coordinate system is a geographic coordinate system. If you have ever used a handheld GPS, this is pretty much what it is dealing with, latitude and longitude. We call, this one is actually kind of funny because I don't agree with this particular graphic, because this is a curvilinear coordinate system, not a Cartesian coordinate system. But we'll leave that for debate later. I'm teaching the slides I've been given. But if we were to ignore the graphic And we were to talk about Cartesian. Cartesian is the X and Y coordinate system. So if we were to just look at this slice in here, notice that those two are straight lines. That is a Cartesian coordinate system in the center, because it's got a right angle and we got a point up here. So it says it's a series of equally spaced vertical and horizontal lines. And so that means that we can easily break it up, as you've seen on pretty much any graph. They're nice and orthogonal to each other. And then the point can be set based on that grid. So we create this grid of equal spaces, and then we just place that point. Then we have the curvilinear coordinate system, which so this is actually geographic. The previous one should say Cartesian up here and not have this graphic, but this one is latitude and longitude. It's a curvilinear coordinate system, and so now we're basing it on a curved surface. So we often use degrees, minutes, seconds, which if we say degrees, that's how many degrees it is. Minutes is the first 60 seconds, or first 60 minutes in an hour, and then the seconds is 60 seconds in a minute. So we break it up like that, just makes it a little easier to read. Very, very common in geomatics. If you were really interested, I can always do up a little lecture on that. We also have degrees and minutes, and then we also have decimal degrees. Then we have a projected coordinate system, and this is when we take our round surface and we put it to a flat surface. So a globe is round, and then we have to try to put it onto a piece of paper. So this is what we consider a projected map, or map projection, and it's projected coordinate system. So a good example is UTM, or Elber's equal area, or the Robinson. UTM is very, very common. You've probably seen that before many times. And so that is one of the coordinate systems that you can use. And it's actually much easier to use the mathematics on it and to use it as a reference, because you do have a zero in some way. And so the next, continuing on with projections, every map projection has some sort of distortion. So we cannot make this perfect. There's some sort of error that's going to happen, and it's going to look funny. So for example, here we can see, whoa, this is really bloated here, and Canada suddenly doesn't really even exist. It's a skinny little line. So everything has some sort of distortion, and then what you want to do is select something with the least amount of distortion in your map, or choose the map projection that provides you with the information that you need that is accurate, ignoring the non-accurate data. So something like this may be very, very accurate and provides the least amount of distortion for the purposes of that map. So distortions, there's 4 different kinds of distortions. There's shape, area, distance, and direction. So shape could be distorted, might look a little funny like the previous one. Area means that the actual area of the land doesn't look the same. So I mean, here it looks like almost US is the same size as Canada. Distance is another one. So if the distance itself is distorted over the same distance on the map versus on the ground. And then direction. Sometimes it doesn't go the same direction. So we're going to spend a little bit more time discussing these in the class in terms of the discussion boards. So, but please read the textbook as well, because you're going to find that those 4 are very key to what your map's going to look like in the end. So as a summary, the coordinate systems are extremely important so that we can put data together. We have unprojected data. And so Cartesian can be in X and Y, but if you're going to do it in degrees, again, like I said, I don't agree with this. If we're going to use it in degrees, it is actually latitude and longitude, which is a curvilinear coordinate system. Then projected is displayed in meters. So that is, again, depends on the coordinate system, but generally for what we use in this class, if we use a projected coordinate system, it's in meters. And what we do is we take our round Earth and we flatten it onto a flat surface. So that is what is happening, and that's why we end up with some distortions, because it's just impossible to make it a perfect round surface to go on a flat piece of paper. So make sure you do your readings on Chapter 1 and 4, and then there's a link here that you can use to check it out and see this unique option. And then you can get started on Assignment 1, and I look forward to receiving that. So thank you very much, and I will see you in the next objective.